Last time I joined the Geoscience Summer School was in 2011. That's the time I started using open source software. With the help of this kind of open software, I finished my PhD and I get doctor. After that, I keep using the open software to solve in my research. As myself, I benefit a lot from open software. That's why I come back and want to share some experience in the now my research now only mainly focus on the urban studies. So today my talk is named Urban Sensing and Computing. Here's the outline of my talk. Focus on the first is a short introduction, followed by the big data in urban studies using the China as a case study area. Last, I will share my experience that using geocomputation with open source software. First is a short introduction to tell the story of urban studies. It is well known that China's extraordinary economic boom has gone hand in hand with urbanization. Now, China has more than 8 million urban populations. Its project to reach 60 by 2030, a very short time, a very rapid urbanization. But this kind of rapid urbanization brings a lot of problems, like the traffic transactions, air pollution. Our urban sustainability faced a significant challenge. You know, city is a complex giant system. We need smart and intelligent ways to manage it. You know, big data from Earth observations to our daily life, it do provide a new way to understanding our city. The traditional way to model our world or our city is commonly like this, using this kind of remote sensing, GPS, and incorporated statistics or field survey. We bring all this kind of data in a GIS system, and we analyze this kind of data. I call this kind of a framework like the Urban Informatics 1.0. With the rapid development of the RCTs, means the internet communication technologies, our city become sensible. From various sensors, from the traffic, transportations to the air quality monitoring. Actually, everyone could be the sensors, especially when you're using your smartphones. Besides, we have a new technology that provides a new way to understand our city. This technology has a same character, that is to simulate human beings' ways of thinking. For example, the cloud computing like the brain, human brain, artificial intelligence, like the way our thinking. And the mobile internet, that the neural network transmissions, and the internet single sensor network, like the sensory organs. The social media, like the social way in the cyberspace. Can this kind of new technology help us to achieve a more sustainable world? I think you may know the UN's Sustainable Development Goals by the 2030. For Goals 11 is concerned with the city. The Goals 11 is sustainable city and the community for our cities. As a researcher in the urban studies, we try to use this kind of new technology to achieve a sustainable city and to improve the quality of urban lives. So the second part, I want to introduce the research framework that I want to adopt big data in my urban studies. First, I proposed a framework for this kind of urban sensing and computing. The definition of this concept is that it is a crossover study that investigating the use of digital sensors to obtain computed and analysis of urban dynamic environments in order to achieve more sustainable and efficient cities. It is a cubic framework. It combines the feature space, skill space, and mapping space. I will introduce this kind of three space. Here is the explanation. Feature space means we study the variety of our cities, including the physical city and the virtual city, from the environment, land use, transportations, human being to economy. Skill space means our study skills from in the spatial, from the building to parcel to block to our above and underground and indoor and outdoor space. And for the temporal scale, we study the history, the today and the future of our city. The mapping space means how do we sensing this kind of data and represent our cities. To be specific, I divide the city space into 4 categories, you can imagine. The first one is the physical urban space. The second is concerned about the social economic of our city. The third is the two is about the human being, because why we are a city, because humans come together in a city. The last one I'm concerned is about the cyber urban space. I will introduce. First, is about physical urban space. It means we're sensing our physical structures of our cities. The target is to get the basic information about our city, like the land use, land cover, building, road, and the greens. Second is human activity space, means sensing human activities or the behavior with this kind of spatial temporal big data. The target is to understand human dynamics, mobility, and the living behavior under the mobile phone and the smart car data. The third is social economic space, because it's also very important. It refers to sensing urban social economics with Internet of Things, using the electronic business data, which adopting the social economic related geospatial big data to understanding the social and economic system. The last one is about the cyber urban space. Yeah, the target is means sensing urban in a cyberspace with social media. Yes, we have physical space and also the cyberspace. The target is understanding citizens' behavior or understanding urban environments through online social media, and studying the relationship between this kind of physical space and cyber urban space. So we come to the urban informatics 2.0. It means urban data science. That means we can using this kind of new technology to sensing our city, computing our city, and make a better decision for our city to achieve a sustainable smart city. After this kind of introduction framework, I want to introduce some specific research that I carried out in last 3 years. The first one is about in the physical urban space to modeling the dynamic urban structure. The second one is about sensing the Chinese dynamic. The third one is mapping urban sustainability. The last one is sensing citizen emotion, and PM 2.5. I will choose one by one. First is about the physical urban space. Data is the center of big data. Yes, we spent more than 3 years to collect a variety of data. Now we built actually is a China Urban Big Data Center. The target is to contain a pan space, the full pan space, the multi-scale from the block level, parcel level, area or interesting level, building level to point of interesting level, and the data must dynamic about to determine our city. The data volume is more than 100 TB now. It covers almost means all cities in China. The data cover the pan space. This kind of pan space data was integrated and fused. For example, for each parcel, we may have the information of urban fundamental GIS data and the sensors, economic sensors, and the human behavior data. For example, the mobile phone positioning data for each land parcel to tell how many people in activity in each land parcel, and also for the social media checking data. For example, I tell for each land parcel we have tremendous of data. They have very high dimension. For example, 24 hours plus the whole year, we have this kind of mobile phone positioning number to display this kind of land parcel. Different land parcel may have different lifestyle. They may be the living place, working space, or the outdoor or indoor space. How to determine this kind of detailed land use type? Because we know remote sensing can only tell the land cover of our nation, but our city do not know the detailed land use function of our city. So we adopt this kind of tensor because does anyone know the TensorFlow developed by Google? We adopt the TensorFlow, this kind of artificial intelligence algorithm, to classify the detailed land use class in all Chinese cities. We divide the urban area into 20 classes. The overall accuracy achieved more than 90%. Besides, we have, I call the previous map the urban organs, like organs of human. Cities also have the cells. Cells means we understanding our detailed urban structure through this kind of point of interesting data. So I think some do you know point of interest data? POI data. Each point with different color represent different land use functions, like the shop, schools, hospitals, and factories. So it do provide a new way to understanding our cities. Like Shanghai, this map is Shanghai. The city have more than 1 million of point of interest data. Each cell units have its own functions. Like people, urban also have purse. Yes, the transportation like people's purse. With sensing and forecasting the urban traffic congestions with GPS and create floating vehicles data. It also covers the whole nation's very big data. Based on this data, we carry out some research. We adopt this kind of Bayesian model to using this kind of deep learning method to incorporate the spatial temporal correlation to predict the traffic congestion in the next 5 minutes. The forecasting accuracy achieves more than 85%. This is the story about the physical space. Next, we concern the human. Human space, we want to answer the question, where are Chinese and what's their mobility patterns? First, it talks the story about the dynamic population mapping. We build a hybrid high-resolution models that combine the commonly used sensor data and this kind of geospatial big data, like the mobile phone positioning and this kind of POI and this kind of social media check-ins. We can so this this model F could be traditional one like the geostatistic, like could be the machine learning method like the random forest. The target is to estimate the dynamic population because the sensor only is static. At the multi-scale in the country, whole nations, in a city, and the detail of city. First, we can show the urban rhythm. Yes, here shows the map of Beijing. They have 24 hours data for the smartphone positioning request. Each color represents the number of requests. Using this kind of mobile positioning data, we can map the city dynamic structure with very fine spatial temporal skills. We also can map this kind of human dynamic in the grid level. For example, the dynamic population mapping at 100 meters resolution was estimated by using this kind of sensors data and multiple unique spatial temporal big data with hybrid area to point geostatics models. Here is the daily life, the daytime and nighttime of Beijing's population distribution. In the whole nation, we have collaboration with the Tencent company. You may know, do not familiar with Tencent family, maybe you know the two apps with WeChat or the QQ. Yeah. Tencent is the largest social media company in China. It has more than 800 million activity users per day. It generates more than 600 billions location requests per day. I have accessed more than a whole month of this kind of very, very big data because they do not have a method to processing it. Because I major in GIS, they find me, I can manage this kind of data. We try to tell some story from this kind of data. The last one is about the whole world. We're mapping the Chinese footprint worldwide by using this kind of 4 million Weibo check-in. Weibo is equivalent to the Twitter. Twitter is blocked in China, but we have our own social media platform. You can see the digital footprint of Chinese. Yes. If I post a Weibo in here, I have a digital footprint here. If I zoom into the Europe, you can see Chinese are everywhere because only Chinese using this kind of social media. After understanding where the Chinese, we went to how to track Chinese mobility patterns. I also carried out some research using this kind of Weibo social media data. We know understanding the individual human mobility is one of the fundamental importance for many applications, from urban planning to disease splitting and the traffic forecasting. Here, we propose a social media check-in data as the proxy for human mobility. As it relies on the public available data and provide high-resolution positioning when users optimal to provide the geotag of their post. If I register my Weibo in Beijing, I come to program and I make a post. It can track my mobility. That's the main story about that. The Chinese mobility pattern could be measured by this kind of big data computation strategies for the individual of hundreds of millions of the individual spatial temporal footprint trajectory. You can imagine, if the big data, the users come very, very big, we can get the, if we aggregate them, we can get the main result. We found the dialect-based culture ties controls the Chinese mobility patterns. We find why people mobility lacks these patterns. Our study do provide a solid evidence that social media check-in could indeed be a useful purpose to tracking and predict human movements. Here shows the results. Here is a city-level Chinese mobility origin and destination matrix. You can see the red indicate many people mobility between each cities, and you can why is the red in there because this city was in the same province. If we project this to the geographic space, we can get the map like this. You may see I don't use social media. Your result may be biased, so we need to validate our result. It's very sad because China do not have this kind of city-level human mobility data. So, but we have this kind of data during the 6 sensors. We have this kind of province-level data. If we aggregate to our human mobility pattern to the province level, we find, okay, they have very high correlated. Recently, I carried another very interesting research because we have millions of, hundreds of millions of users for the social media data. We know what's their relationship between each other. That's the following shape. We know their friend in the virtual city. Yeah, we tell the story of city friendship. If they can get how many friends that Beijing have, yeah, and where they are friends, of course, in the social media. The third one is about the social economic urban space. We try to mapping the urban sustainabilities. As I told before, UN have a very big plan for the sustainable development goals. In this year, I started a project with the name of SDG China. We want to measure the sustainability of China. First, we build a website with SDG China. We just translate all this kind of SDGs plans to the Chinese people because it is in Chinese. Let people to know what does SDG mean. As a spatial researcher, we want to measure this kind of SDG indicator using spatial, like this kind of Earth big data. That's the purpose of my study. Until now, I only concerned with this kind, the target 11, the sustainable city and the communities. They have 10 target and 15 indicators to measure our city sustainability, from the environment to the public transportation and the housing in our cities. First, I take a public transportation example. This year, I just collect more than 1 million of this kind of public bus line in China. Yes. We first want to map this kind of map to measure the public transportation accessibilities because it is an indicator in SDGs. Another example is about the housing. We get this kind of transaction data from the land and housing panel price for almost for each community of the whole China. The purpose is to analyze the housing price spatial temporal dynamics. Also for this kind of land transaction dynamic in Palo River Delta. This map was generated by using the GG map package using R. The targets, the main purpose of my SDG China study is to try to map the SDG indicator in the 1 kilometer spatial resolution to measure the sustainable development and try to make smart decisions for the future planning. The last one is about the city, the cyber space, tells the story of citizen emotions and the air pollutions. As the largest developed countries, China has a significant air pollution problem, you know. High-level ambient air pollution causes sickness. Exists a mortality risk. Most of current plans care about air pollution and health impact. As we know, air pollution may also have some affect citizens' happiness and lower the working efficiency. How to measure this kind of social cost of air pollution is the question we want to answer. First, we're using this kind of NASA MARI 2 models to measure the whole world PM 2.5. This is the basic data that we need. We adopt citizen sensing to measure citizen emotions and study their relationship between the particular PM 2.5. The basic idea you can see is that we're using billions of geotagged Weibo's posts that calculate its sentiment metrics. That using the natural language processing, it is a machine learning method. For example, if one posts, "What a lovely weather, let's go camping." After using this kind of machine learning, the natural language machine learning, we get the 90. Yeah, but if we post today, it's heavily air polluted. My nose is stored up. The sentiment index only equal to 10. If we have billions of this kind of posts, after control, the other factor may affect human expressed sentiment, like the weather, the event, income, and city properties. We can measure the city. We can finally distinguish the relationship between this kind of how PM 2.5 concentration affects citizens' emotions. The main finding is that one standard deviation increase in the PM 2.5 concentration is associated with 0.05 to 0.06 standard deviation increase in sentiment index. And one standard deviation increase in this kind of city's PM 2.5 concentration can be offset by 6.5 thousand yuan to increase in cities. That means money can buy happiness. Here is a map of geography of Weibo post. You can see and the PM 2 concentration and the sentiment index. And this line shows the whole nation's relationship. We can see in the national level, citizens expressed sentiments was decreased with the increase of PM 2.5. This is the main result, but we want to find some heterogeneity effect of air pollution on sentiment in different days. Here's a story for different days. For example, for the holiday, people are much more happier. For example, the terrorism, people express very depressed. Here is the last one is the PM 2.5 effect. Holiday do have also, if today is a holiday, have a very high air pollution, it will affect people's sentiment much than the working day. The high temperature and the global warming, for example, this kind of high temperature will significantly affect human expressed sentiment. We also test the heterogeneity effect of air pollution on sentiment across population groups. For example, the male and female, as we know, female more sensitive to the air pollution, and the local people is more sensitive. And we can see 3 income group, both the rich people are less sensitive to air pollution than the middle class, because maybe the rich people they can buy the air filtering to clean their clean the air. After tell the story about the urban studies using big data in China, I want to share some experience by using the geocomputation with open source software, especially the OSGeo software. Here is a table of tools that data scientists need to master, from the storing data to modeling and visualization data. Most of them are open source, but some of them are commercial data. The most wide use language in data science is also the R and Python. We know life is short using R and Python. This map, maybe you are familiar with that. It tells a story about our ecosystem for the data science by the Hadley Wickham from our studio. After this summer school, I think everyone will use this kind of package in your research. Also, for the Python also have a numeric of package that can to perform the data analysis. Actually, here is the main open source software in OSGeo that I used maybe commonly in my research. For example, I'm using this kind of PostgreSQL and PostGIS to do this kind of data management. If you have very large of big data, you must storage and manage them in a database, not in files. Then some core package like the GEOS Project 4, they have some fundamental functions that you can manage this kind of spatial data. After that, you can use some open source GIS desktop software like QGIS, GRASS, and Saga. And the last, if you want to publicate your data in the website, you need some visualizations using the WebGIS, like the Leaflet and the GeoServer. Yes, here's my geocomputation workflow. First, using the maybe Python to managing data in PostGIS and PostgreSQL, and then using open source GEOS. R have an interface to a variety of open source software that's like RQGIS, RGRASS, and RSaga to using the basic functions in the open source OSGeos. For the visualization, I commonly use JavaScript to do this kind of WebGIS visualization, as I showed you before. The whole processing are mainly on the cloud. By using the Linux cloud with the interface of RStudio Server. Yes, do you know RStudio Server? You can use RStudio Server to access your cloud computing this using the RDEs. Yes, here's a summary. I want to talk to you. Besides the big data, we also need big thinking. That means we need big models. Big data plus big model, maybe we can answer some big unsolved questions. But, you know, this must need people in collaborate with each other. It is better to cross-disciplinary collaborations. To end of my presentation, I want to refer to the Michael Goodchild paper in the PNAS. I think it is the future of geoscience. The subliminal GIS, geographic information from satellite-based and this kind of ground-based sensors have extremely rapid and encouraging brief a new force and big data pregnant of science that emphasis what? International collaborations, data-intensive analysis, huge computing resources, and high-end visualizations. Yes, this is the end of my presentation. Thank you. Any questions?
Okay, thank you. Are there any questions? Comments? Yes.
You use an awful lot of social media data and data from CAS and the like. I wonder if you could just tell us a little bit about the process of getting access to that data and whether that was difficult and and how you went about that.
Yeah, it still have some learning curve, especially you are not familiar with geoscience. Yes, that's why I want to show these sliders that you'd better find someone already expert in this field. They collaborate with each other. Yes, you may have your special domain. Yeah, you are expert on it, but you are not good at big data analysis. Yeah, you can find some collaborators. Yeah, thank you.
One more question.
How much of the data is publicly accessible or open data?
I think you can see the two main kind of big data in my study is mobile phone data and the social media data. Mobile phone data is closed, but the social media data, we can access this kind of data via the API. Yes, I think half. Yeah, thank you.
So the companies like Facebook and Google and all these big corporations that have a massive members, they also collect this type of data, and Facebook's been mapping a population density of the world. So they made a map in very high resolution, I think even like 30-meter resolution. And they said they're going to share it publicly, but I didn't see it. So they were just promises. But yes, I see with your map what you made, the footprint of Chinese people in the world. It will look something like that, yes. Okay, thank you. We have to continue, I'm sorry. So thank you for your talk.